All right, let's talk for a minute about nuclear power. One of the real problems, we were just talking about decay, nuclear decay. And we had said that the stuff, radioactive materials, will be around for a really long time because the half life of some of these is, well, like uranium 238 has a half life of 4.5 billion, 4.5 or 4.8, 4.5 billion years. It's about the age of the oldest rocks on Earth. So it'll be around forever. Um, Others have, thousands of years. So the problem that we have with nuclear power plants, the fission plants that we are used in commercial operation now, is that they produce a waste product that will be around and be dangerous for thousands of years. Now, we have a site in Nevada that was designated as the nuclear disposal site. It's Yucca Mountain, Nevada. And if I'm remembering right, it's an old salt mine area. And so the idea was you take all this nuclear waste and you put it down underground there so it's not as likely to cause problems. People are not likely to be exposed to it. Now, what happened? Most nuclear waste from nuclear power plants is not stored there. Why? It's because the states that it would have to travel through to get to Nevada, they said, no, 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 we're not going to let you move that dangerous stuff by train through our communities. And so, in effect, what's happened is these nuclear power plants, what do they do with their waste? It's there at the nuclear power plant. So, which isn't an ideal situation at all. The problem is, how do you, what do you do with this stuff? Now, we unfortunately have had some accidents and near accidents dealing with nuclear power plants, and the one that that we're going to talk about is Chernobyl. It's the older one. We had one recently in Japan, a disaster. But if we talk about Chernobyl, what happened there, they were doing a test. They were doing a safety test at Chernobyl. It's you can't make this stuff up. So they were doing a safety test at Chernobyl, and it got out of hand. What happened is, of course, just a little bit of background. In that area, there's about 120,000 people within 30 kilometers of Chernobyl, or there was. And they were doing an electrical safety test, and let's see. So what they did is they intentionally interrupted the flow of cooling water to the core. And when they did this, they didn't leave enough of the control rods. Remember, we said we have graphite control rods that control the reaction. Well, they interrupted the cooling water, and they didn't leave enough of the control rods there. So we ended up having this huge disaster. The extreme heat that was generated ruptured the fuel rods, releasing the fuel particles. This is the radioactive material, which caused an explosion. So within seconds, the reactor core was destroyed. Apparently, when the graphite, the control rods, when they're sprayed with water, they will produce hydrogen gas, which produced another explosion. So one thing after another, a lot of explosions going on. And so what happened is it blew the 4,000-ton steel top off of the core. And radioactive material was released. Now, what was released? Radioactive iodine and radioactive strontium. Now, what happens with radioactive iodine? Iodine is concentrated in the thyroid gland. It can lead to thyroid cancer. And radioactive strontium is is very similar to calcium. So if you're in an environment with a lot of strontium, your bones, rather than being made all completely of calcium, it incorporates strontium in there as well. Well, strontium's radioactive. So in both cases, it's really bad. This is called bioaccumulation. And so both of these radioactive substances are picked up into life and caused a lot of problems. Basically, they did end up covering the core of the nuclear power plant to contain it, but it's a ticking time bomb to this very day. I just recently saw in Scandinavia they monitor for radioactivity, and they'd seen a spike in radioactivity, not to dangerous levels, but higher than normal, higher than it has been, and it's attributed to possibly some leaks in Chernobyl, which is quite a ways south, but it's sort of due south of the eastern parts of Scandinavia. Here in America, in Pennsylvania, we had a near disaster in 1979 ourselves. The 3 Mile Island, there was a release of radioactive gas, but we did get it under control. And then Fukushima in 2011, there was an earthquake and tsunami tidal wave, which flooded, and the tidal wave flooded and knocked out the generators that pumped the cooling water. And so what happened, it's similar to Chernobyl in effect, because no cooling water, you had this high heat and an explosion. So because of all of these experiences, nuclear power is on the way out. And quite honestly, we were talking about sustainability in one of the last chapters, and we had said the triple oh shoot, I'll have to look up my own terminology, but we had said businesses should think in terms of optimizing profits, taking care of the environment, and taking care of community. This nuclear power plants certainly take care of the economy, but they have the potential of not fulfilling those requirements. So if nuclear power is out, what does that leave? Solar, the sun. We're going to talk about solar power next.